afternoon. Right, today we're going to talk about, battery storage. Now, it's not related to Balloon Project. That it's taking a little bit of a pause for now. I need to basically make some attachment to my printer. But we will talk on a separate matter. So, energy storage obviously is something that is a topic that comes up a lot. Cars, solar, anything with renewable energy needs some mechanism of storing it. For nighttime. But one of the typical sort of battery sizes is called an 18650. There's various ones like a 2170 as well. So Tesla use, for example, 18650 cells. They're changing, I think, to a much bigger. I think it's a 2170. I can't remember the name exactly, but it just means the size and proportions are slightly different. And so the 18650 has been around a while. They're quite cheap. To some degree you can get them quite cheap. You can even get recycled ones. They're basically these guys here. Quite a nice form factor. E-cigarettes use them. Now they come in various different flavours, you might say, not just colour. So sometimes you need higher capacity but slower output. Sometimes you need high output, like for e-cigarettes, but less capacity. So they do vary. The cost goes up if you want slightly higher capacity but faster output. Don't go too cheap, obviously, with them, but you got negative, positive. Here's a kind of a semi-naked one. This is what they kind of look like under the skin. You've got an end cap on it on one side. Now, it's very important you have, if I find you eventually, it's very important you have the protective cap on, because between here and here on the end is the positive and negative, so you can easily put a screwdriver in and short the battery out, and they get very unhappy and could explode. But what I'm going to go over today is I'm going to make a battery pack, and I'm going to show you, how to DIY it. So these are actually recycled cells. Here's some actually, most you do get them in laptops sometimes, but generally these days laptops contain the flat ones, the lipopolymer style ones, a bit like these kind of shapes. But these are actually from a laptop. Here's some batteries here. Normally I would file the ends off a bit better, but the downside of that is, in this case I'm not going to do it today because you just wear the end off the paper, then you create a short circuit. So you can be very careful with recycling them, and also, more importantly, you need to test them. So you probably saw on this one it had numbers on it. So this means I have two test devices I'll show in a sec. This is 2.765 amp hour, and it's 11 ohms resistance for the battery. Not so much caring about that unless it's over 100. Then I start to look at that battery and go, maybe that's not the right one. And okay, I'll show you the device that I'm using for testing. A very cheap one. Here it is. Basically, this has a few modes on it. Discharge, charge, test. Test what it does, it charge it up, discharges it, and then recharges it, and it will give you how much capacity it had. I'm not going to worry about these because I'm actually going to keep them. I'm just going to show you how to construct a pack. Very basic one. On array of batteries, I should say. You can buy these. They actually interlock. You can buy the sheets as well. I just like the fact I have more flexibility here. So, I'll also show you some characteristics of this battery. Each battery has its own data sheet, so you need to look it up. In this case, this is a 3100, so you see it's obviously not the newest of cells. Typically, a LiPo and a Li-on full charges are about 4.2 volts. So if I put a tester across this, I'll probably get about that. Completely flat is 2.5, but generally don't do 2.5. Just hold it to 3. It will keep the battery in better shape. Typically, if I'm going to use a long-term project for this, I wouldn't use the full capacity 0 to 100% all the time because it puts a lot of wear on it. And you only get about 500 cycles in new from these. So I will run probably 3.5 to 3.95. It'll be about 50% of the capacity, but you'll get a lot more cycles out of it because it reduces the wear. This particular battery also is noted to have a 2C capacity on discharge max. What that means is 3.1 amp hour times 2 in this case, so max of about 6 amp draw. It will get hot when you do that, so if you look at the data sheet you can see the temperatures it will be at. If you put it at that, I wouldn't recommend doing that. 1C is probably the max, I would say, and then the charging is always half a C, so 1.5 amp charge. Again, slower the better for the battery long term. And if you want to make high voltage packs, what you can do is you flip them up and down, upside down, you know, constantly, so it'd be like that, and then you bridge the gaps on each side. Now let's touch on the aspect of sticking them together. So let me move the old whiteboard out of the way. So for generally batteries like this, you use well, nickel wire basically, but this is a cheaper alternative. This is steel-plated nickel plated steel. Not great. Like, I wouldn't want to build too many amps with this. The difference between nickel and steel is probably like 8 times less current for heat output because it's quite high resistance. But just as I have some spare, I'm going to show you. So you have some of that. You need to spot weld as well. So this is a 30 quid DIY spot welder. Like, if you want to do a lot of these, I recommend buying a better one. But I just wanted to play around with it, so I got one of these. And then an energy source. I'm using some LiPo batteries, but you can use a lead acid battery with a high enough amp output, but these should suffice. Now, why do you need high amp output? So this needs, on a 3S battery, what these are actually, 40 to 70 C. So if we do the math there, 5 times 40, 5 times 70, it needs that many amps at a pulse. It's a very short pulse, and it melts the wire together. Melts the tabs to get the tab strip to the top of the tab of the battery. That's quite a lot of amps, probably 150 to 200 amps. So having a good battery is good because it won't kill the battery eventually either. Okay, so I'm going to do a 6S battery, 1P. So that means 6 in series, 1 parallel. That'd be important later on, and I'll do in another section in this video. So as you can see, I'm flipping them. Now, again, don't obviously jump straight into this because it's really important that if you've got like batteries of mixed varied sizes, these are different. There's a 100 milliamp hour difference in capacity. Try and get them as close together as possible. And generally, if it's over 100 ohms, obviously keep away from that battery because it means it's got a high resistance output. So if you want to pull a lot of current, it'll get warm quicker than other batteries, and the voltage will drop sooner. So these aren't compatible really to be in the same pack. I'm not so much caring today, as I said. I'm just showing the process very quickly. So let's stick those together. Stick my little frame on top. So now you can see a bit more tidy. So we are normally, this might not weld great, but we'll find out. I'm going to kill some scissors. So now I'm going to create those little strips between them, like this. And we'll just do a test to see how that goes. Oh. That going there. So you can see that the whole idea of bridging together. I'm going to plug the old spot welder in. Obviously be careful if you're getting really cheap ones. This one has a nice little interface. So then it will have, you can see that, but power setting, input voltage, so we're going to up the power to 20. You just got to try it, see if it welds. If you can pull them off, then off the battery, it wasn't good enough. So this is set to auto, so when I cut these down, hopefully I can show you. See? Obviously you want to be direct down as possible so you get the most electrode contact. And all it's doing is literally quickly melting the two surfaces together. I normally do 6 points. Enjoy the sparks. If it's sparking a lot, it means you haven't got great contact as well. Alright, so now you see there, the little points. Now, I can't actually pull this out because the bridge is contact there, but a good test to make sure is obviously test it on a single battery and then just try and pull it off. And if it's really easy, then you need to up the power basically. But in hindsight, that's all it is really, just to connect packs together. Let me just do a few more strips, kill these scissors a bit more, be sharpening those up. And then I'll show you with a multimeter how that works, how the pack's voltage looks then. Now, there are other things you can buy as well. Like you don't have to cut them, but this is generally the cheapest way. Just labour intensive. I'm going to do 4 here. Beautiful. Flip it over. Oh, we actually need to do 3 on this side. We'll do them all. Basically what this is doing is shorting out those batteries, but those batteries can output a lot of current. So as it's only a burst, it's okay. Okie dokie. I can zoom down and show you a bit closer. There we go. There we go. So spot welding is also used on cars, like to weld two panels together. They two layers of metal. They have a pincer on each side, both electrodes, and quick pulse melts it together basically. I'm going to show you again. Let me go down the top view now. Otherwise you just melt through your electrodes a lot quicker. And this side as well. You can have a foot pedal for this one, but to be fair, always fine. If I don't want it to move, I just hold it with one electrode down first. Okay, so let's turn that off. Leave you out of the way. It's getting a little bit warm now as well. Alright, let's see how this pack looks. So 6 times best case 4 volts, because I don't know what the state of charge is for these. What's that in English? 24-ish volts. So flip it open, positive, negative, make sure it's not an amps or. See what we've got. Let me zoom. Let me pull it over so you can see it a bit better. Alright, so battery pack's voltage is 23. Then if we jump to, this should be like 8-ish. This is 2 cells. And then if I was to go the other side, I will try to. It should be 3 cells, should be about 12. 4 cells should be about 16. Yep, 5 cells should be about 20-ish. Yep, and then obviously back to the full pack size. Now, what you should also do with this is balance them. So pretend these are all the same capacity or close match. You need a BMS. Well, you don't need a BMS, you need cell balancing. Because what can happen is over time, these can come out a little bit out of balance if they degrade. You need something to keep them in balance, and also if they go too low or too high, to cut the circuit, basically to take it offline, because at that point, if it goes too low, it damages the cell. If it goes too high, you're at risk of fire or something really bad happening. But there you go, 6S battery, done in a few minutes. Alright, anyway, so on to the next thing. 1 second, let me just get something. Alright, okay, well, so that's a small battery pack. I'm going to make a bigger one, just because I want to use it for a bit of storage, you know, a bit of energy capacity. So let me just drop that on there. So here's something I've pretty heavy, by the way. Here's 196 cells. I've already pre-tested every single one, and aligned them in 24. Oh, sorry, you didn't see that. Wasn't that zoomed in? There you go. I've aligned 24 rows of 8, and I've done kind of what we did earlier with this little guy, except there's now 8 in a row. And I've tested them all, put them on the spreadsheet, ordered them in such a way that they are each like set. Every one is about the same, well, closest to that set. So you'll probably find that this side has a little bit more capacity than that side, but not much to be worried about. What's good? But anyway, I've got some nice, it makes my life a lot easier because I worked out I want to pre-cut all those strips right pain in the ass. You can get some like ladder stuff here. It's called, what's it called? Oh, I can't remember the name of it. If you want it, let me know. But this is handy because it's actually already the correct sizes. Let me just stick it down somewhere. To sit between every single cell, so I don't need to cut a strip going that way and I don't need to cut a strip going that way. I just go happy tappy. And also, quite more importantly, you notice it's got slits in it. That's there, so when you put the electrode on this side and this side of that little gap, instead of it going straight through the metal to the other side, it has to go through the battery and out the other side, so it forces more power to go into the points that it goes through the battery. Basically, it's for a better weld. This is also pure nickel. What the other stuff was, this can handle a lot more current. Not as good as copper, but the good thing about this is, yeah, it doesn't rust. It's very corrosion resistant, Now be careful if you ever do buy this that you want to cut some off, scratch it up, throw it in some salty water overnight, and see if it rusts. If it rusts, it's not pure nickel, it's probably plated steel. But if it looks shiny as it went in, beautiful, it's probably nickel. Nickel's quite soft anyway. So what I'm going to do here is, on this pack, I've got the positive, I've got the negative, and I'm going to daisy chain them. So the first row would be here basically, and then the second one would be there, the third one would be there. No, I'm saying that out loud, it doesn't sound right. Brain, come on, you can do it. 1, 2, 3. Yeah, that's correct. Sorry. Brain was like, nope, that doesn't work. I was like, you got 3 across the top, and then it loops back around here, so to connect this side. So, in essence, if I can use this as a diagram, put these on this side. So it'll go. That's why we've got a plate here. Go up again. That's why we've got a plate there, and again, and then it'll come up that way. Good, because then it means my 2 contact points are on top, and I do have some, I need to test it actually, I do have some nickel single strip that I'm going to use for the end points. More importantly, I'm going to double it up because of the amps. There are charts online if you want to have a look for nickel strip at certain thicknesses. It will tell you how many amps that can roughly go through it, but it's, you want to over-engineer when it comes to battery pack amps. This is fine up to a certain point. But on the ends I'm going to need at least twice the thickness to do like 30 amps that I want to do. Now let me just work out how to make this stay down. I could spot weld the centre, but I'm just very careful. If I have it misaligned, it's going to be a right pain in the something, let's put it that way. What I might do is take down the ends and one sec. And by taping the ends down, hopefully it'll stay in place. Because once I start welding, once it's in the wrong place, it's impossible to pull back around. So if we put a bit of tape on this end, and my lights go out. There we go. And we'll try that again. So I'm going to line it up with the end. Okay. Hopefully that will stay. Line it up with that end. Then I probably will start from the centre as long as the ends are still lined up, because it just means that if there is a temperature increase that causes it to warp, if I start going that way or I start jumping all over the place, I'll start buckling up. Not very ideal. So let's get the old Sparky machine out and position that adequately. Oh, it's decided to come up. Nice. Let's get this going. Normally I hang it above again, straight above this bench, just because it means I don't have to lift it as much. Let's try that again. It's already misbehaving. How dare I? Okay. I'm going to tack it in the centre. So it looks okay. So I'm going to go to each side of the hold it there. You can ignore. So I need to put the power up on this guy. Sorry about the beeps. Okay. Nice little kick. Looks like it's holding. Go to the other side now. Okay, so you can see, ooh, that's nice and warm. It's now a bit more cooperative. As I say, it's quite hard now to misalign it, because they are saying that you can. It will become hard to misalign it in a sec. So let me retake that down in position. Okay, now it's harder to move. Okie dokie, so I'm going to fast forward this now for your luck. This will probably take me a while. But yeah, I'll catch you in a bit once I've done it. Okay, well, finally, I've done most of the spot welding except for both some tags on the inside, so let's awkwardly flip it. This is always a fun exercise. Fuck, it's heavy. Excuse the French. Let's put that back down carefully. Okay, it's a bit more rigid now as well. Looks like the whole battery pack's on a slant, but maybe that's my eyes. I think it is. Okay, let's test this. Should read about 33, 32 volts. 33. Should be fairly similar. See, it's different. Obviously, I need to connect these up. What I shall do, one moment, please. Okay, this is the nickel single strip that I was talking about. I'd have to have made like 400 cuts to this if I wasn't to buy that. So I think a bit of a time save. And now I haven't tested this so it's pure nickel, so I'm just going to really hope. Worst comes to worst, you just bolster that line up with some wire. Okay. So what I'm going to do is let go of that. Is stick some kitchen roll across this so I don't accidentally short the pack out. Obviously, turn the fan off would be a good start. Just in case I let go of that wire and it goes. It's the noise it makes. Stick you down. There we go. Okay, dokie. Let's destroy those scissors even more. Let's have it a bit longer than we need. Now I'm going to double this up as well. Wow, this is a bit harder than I expected it to be. Sorry, microphone. Okay. Welder. This is going to be a bit more exciting. Should tape it down, but you know, that'll be alright. Ooh, the copper does like to stick. Okay, right. Okay, well that's minus twin plating this up. This side, just to hold the amps. That's to a point I'm really happy. So, what I might do is I'm debating whether I should do that in the next video or this video, but I might just double plate that stuff up. But now we should have a nice, well, it'll be a consistent voltage because it'll balance. 33.02. Do I want to double plate it now? I think I'll do that off video because I'll do that in the spare time. But what things left to do? We've got the BMS. I have got in the other room. What else have I got to do? Probably Captain tape this entire side up because because wrong one moved like that, and gets exciting. Let's put it that way. Oh yeah, so BMS connectors, and then the strip, what I'll do in my free time. You've seen me do all this, so I don't think you really need to see me to do two more. But I think I'll do that in the next video. So well, have a nice evening. Catch you next time. Thanks.